On the night of July 1st, 2025, a quiet signal appeared in the data from a telescope high in the Chilean desert. It was just a flicker, one faint dot drifting across a star-strewn background. At first, no one noticed. After all, space is full of motion. Asteroids, satellites, comets, they come and go. But this one was different. It wasn't just moving. It was racing, faster than anything that had ever been tracked before. And within hours, the astronomy community was sounding the alarm. This object wasn't from around here. It wasn't just some rock orbiting our sun. It wasn't coming back. It was passing through on a one-way trip from the deep frozen reaches between the stars. And what it carried with it would challenge everything we thought we knew about time, space, and the age of our universe. They called it 3 Atlas, short for the third interstellar object ever discovered, and a nod to the asteroid tracking system that found it. But names don't do it justice. This wasn't a pebble like Umorma or a comet like Borisov. This was something far more massive. 7 miles wide, a mountain of ancient ice and stone, older than Earth itself. A fragment of another solar system, flung across the galaxy billions of years ago, now screaming toward our sun at over 30,000 miles per hour. Think about that. It would take you nearly a decade to drive around the world at highway speed. This thing could do it in under 20 minutes. And it had been moving for longer than our planet had existed. And yet, somehow, almost impossibly, we caught it. Not with a bang, not with a flash in the sky, but with a quiet signal on a computer screen, a glitch in the stars, a whisper from the void. What followed was chaos. But the good kind. Telescopes across the planet swung into position. Data streamed in from observatories in Hawaii, France, Chile, Spain. Space telescopes like Hubble and Webb cleared their schedules. Scientists dropped everything. Because this wasn't just an opportunity, it was a countdown. We had only weeks, maybe months to study this object, before it vanished forever behind the sun and never came back. This was a one-time encounter with something not just alien to our solar system, but alien to our time, a frozen relic from an era before Earth, before our sun, possibly before the Milky Way even looked like the galaxy we know. And what we began to discover as we stared deeper into its coma, the glowing halo of gas and dust that began to form around it, was staggering. It was already waking up, already sublimating, already releasing water vapor, carbon compounds, and ancient dust from a planetary system that no longer existed. As it approached, we weren't just looking at a comet. We were witnessing the reactivation of chemistry that had been asleep for 7 billion years. But the clock was ticking. Every moment we observed was a race against its disappearing act. Every photon of light was a message from the past, one we had to decode before it slipped back into the void. This isn't the story of a comet. This is the story of a cosmic survivor, a messenger from the early galaxy, and the brief moment when it crossed paths with us before continuing on its journey into the eternal dark. The discovery began like so many others do, quietly. No fireworks, no skywide flash, no dramatic signal from the heavens, just a data point, one small anomaly buried in the nightly stream of observations from the Atlas system in Chile, an automated telescope array designed not for deep exploration, but for planetary defense. Its job is to watch the sky, night after night, scanning for anything that might pose a threat to Earth. Asteroids, rogue rocks, tumbling debris. It does this with cold efficiency, processing thousands of images every hour, flagging anything that moves against the static stars. Most of the time it finds exactly what you'd expect. Known asteroids following familiar paths, new objects drifting through the asteroid belt, maybe a comet or two flaring up near the sun. But on the night of July 1st, 2025, it found something else, something that didn't fit. It was subtle at first, barely visible, a dim dot crawling across the galactic backdrop. But there was something odd about it. The software flagged its speed as unusually high, and when astronomers dug into the data, that's when the real surprise hit. The object wasn't just moving fast, it was moving impossibly fast. Over 60 kilometers per second relative to the Sun. That's not just fast for an asteroid. That's fast for anything. To put it in perspective, that's enough speed to orbit the entire Earth in about 11 minutes. Enough to break free from the Sun's gravity and never return. And that's exactly what the object was doing. When astronomers calculated its orbit, they realized it wasn't orbiting at all. It was flying through. On a hyperbolic trajectory, one that doesn't loop back around the Sun, but shoots past it and continues on into space, never to return. Objects like that aren't from here. They don't originate in our solar system. They come from the vast frozen reaches of interstellar space, between stars, between systems, beyond anything our species has touched. Within hours, telescopes around the world were turning toward this mysterious visitor. Archival data was pulled. Observatories in Hawaii, France, and Canada located older images. It had been hiding in plain sight for weeks, its motion almost invisible as it crept through the densely populated region of the sky near the galactic center, a needle in a haystack of stars. But now that it had been found, the evidence piled up quickly. Its path, its speed, its brightness, all pointed to something extraordinary. This was only the third time in recorded history that humanity had identified an interstellar object. The first had been Oumuamua in 2017, a strangely shaped tumbling relic that sparked endless debate. The second was Comet Borisov in 2019, more familiar in behavior but still alien in origin. This one was different. It was larger, faster, colder, and it was still inbound. The others had been found as they were already leaving, studied only after they had passed their closest approach. But this one we found in time. The Minor Planet Center, responsible for tracking all known solar system bodies, confirmed its origin within 24 hours. It was assigned a temporary name, 11PL3Z, and then a far more meaningful one, 3 Atlas. 3 for the third interstellar object ever detected, Atlas, for the system that spotted it just in time. And while the name was simple, the implications were not. What we were seeing was something we may never see again in our lifetime, a relic from another world on a one-way trip through our own, and it had only just begun to reveal what it truly was. At first, no one could have imagined just how massive it was. When astronomers detect a distant object like this, they're not seeing it up close. They're interpreting faint points of light against a background of stars, relying on complex measurements of brightness, motion, and how that light behaves over time. For days after its discovery, 3 Atlas was still just a speck, blurry, dim, mysterious, but as the observations improved, as better telescopes locked in and began to analyze the light reflecting off its coma, the truth started to emerge. This wasn't a rock. It wasn't a chunk of ice. It was a leviathan, a 7-mile-wide behemoth of ice, dust and stone, larger than any interstellar object ever recorded, and by a wide margin. The scale of it didn't fully sink in until data from the Varus C. Rubin Observatory was analyzed. Tucked away in its pre-commissioning imaging backlog, astronomers uncovered multiple exposures taken days before the official discovery. Using those images, they calculated the comet's absolute brightness and how that light was being scattered. What they found was staggering. The nucleus, the solid core of the object, was roughly 7 miles or 11 kilometers across. That's the size of Manhattan. An object of that size doesn't just reflect light. It commands it, and in the context of interstellar space, it's a giant. To put it in perspective, the first interstellar object, Umanue, was estimated to be between 100 and 400 meters long. The second, Borisov, measured less than a mile in diameter. 3 Atlas made them both look like cosmic crumbs. But it wasn't just size that mattered. It was what size meant. In the world of comets, larger bodies have an enormous scientific advantage. The more mass, the more likely it is that internal layers have remained untouched by heat or radiation. It means better preservation, more pristine material, a deeper chemical record. In the vacuum of space, time becomes still, but only if the object is big enough to hold itself together. And this one had done just that. It had survived the violence of ejection from its original star system. It had endured billions of years of exposure to interstellar radiation and micrometeoroid impacts. And now, as it entered our solar system, it still carried within it unprocessed compounds that had likely been frozen in place since the earliest days of the galaxy. Astronomers realized quickly that they weren't just studying a comet. They were peering into a cosmic time capsule, one large enough to retain heat, shield its core, and preserve the chemistry of another world. Every volatile molecule locked inside it was a data point from an alien solar system. Every particle of dust, a trace of an ancient protoplanetary disk that no longer exists, and the size of this visitor suggested something else as well, something unexpected. If such massive objects were being ejected from other star systems, and if one had reached us now, how many others had passed through unseen? Was this just a rare exception? Or had we been missing them all along? What had once looked like a faint blip in a telescope image was now revealing itself to be a giant among interstellar wanderers. The kind of object no one expected to find. The kind of object that changes everything. And the closer it came, the more it promised to reveal. As the comet drew closer, as its coma began to thicken and its long-forgotten molecules returned to the light after eons in deep space, another piece of the puzzle began to crystallize its age. We're used to talking about age in human terms, years, decades, maybe a few centuries. Occasionally we stretch our imaginations far enough to grasp the age of Earth. 4.5 billion years, or the Sun, which has been burning steadily for about the same amount of time. But this object, this silent traveler from the stars, was even older. According to orbital backtracking and chemical modeling, 3 Atlas is estimated to be at least 7 billion years old. Not just older than Earth, but older than the solar system itself. That means it was born in a completely different era of the Milky Way, before our sun ignited, before the planets took shape, before the asteroid belt or Jupiter or even the hydrogen cloud that would eventually become Earth had begun to form. Tracing its origin backward through its hyperbolic trajectory, astronomers were able to estimate its likely origin point somewhere in the Milky Way's thick disk. That region is one of the oldest structural components of our galaxy, filled with ancient stars that are metal-poor and long-lived, some of them nearly as old as the universe itself. It's a place shaped not by the slow and steady processes we associate with modern planetary formation, but by violent collisions, supernovae, and the raw chaotic energy of a young, growing galaxy. If 3 Atlas came from there, and every calculation suggests it did, then it may have formed during the very first wave of planetary systems, in a time when heavy elements were scarce and the rules of planet building were still being written. And then, at some point in its unfathomably long past, something changed. Maybe it passed too close to a giant planet in its home system. Maybe a nearby star passed through and destabilized its orbit. Or maybe, during some ancient cataclysm we'll never know about, it was simply flung out of its gravitational cradle and into the abyss. Regardless of how it happened, The result was the same. It was ejected, thrown into interstellar space with no star to call home. And there it remained, wandering silently for billions of years, untouched by light, unshaped by tides or collisions, drifting farther and farther from the system that birthed it, until one day it entered ours. The thought is almost too big to hold in your head. For the entire history of life on Earth, this object has been adrift in the cold, while trilobites ruled the oceans, while dinosaurs roamed and fell, while humans stood upright and learned to speak and look up at the stars. This thing was out there, moving in silence, bound for nowhere, and now, just now, it's arrived, not to stay, not to orbit, not to collide, but simply to pass by. A quiet reminder of how old and how vast the galaxy really is. A cosmic relic, older than every mountain, older than every sea, older than every cell of life that's ever existed on Earth. We speak of ancient artifacts here on Earth, bones in stone, tools in clay, ruins lost to time. But this isn't just ancient. It's primordial. A frozen message from a forgotten world, traveling across the dark for longer than we've had words to describe it. And for a brief moment, we have the chance to listen. Long before it reached the inner solar system, before it even crossed the orbit of Jupiter, something unexpected began to happen. 3 Atlas started to wake up from a distance where most comets remain frozen solid, indistinguishable from the lifeless debris of space. This object began to show signs of activity. At first, it was subtle, just the faintest halo of gas around its icy core, a shimmer caught in deep exposure images. But it didn't stay subtle for long. Within weeks, the coma grew brighter, more distinct, expanding outward as sunlight began to touch volatile compounds that had been sealed away for billions of years. And that's when scientists realized this object wasn't just a relic. It was alive, in the only way a comet can be. The process, known as sublimation, is deceptively simple. Solid ices heat up and transform directly into vapor, dragging dust and microscopic particles with them, creating a glowing cloud around the nucleus that we see as the coma. Eventually, that material is pushed outward by solar wind and radiation pressure, forming the iconic tail that stretches for thousands, even millions of kilometers into space. For comets from our own solar system, this awakening typically begins much closer to the Sun, often around the orbit of Mars, when temperatures finally rise enough to affect water ice. But 3 Atlas began to sublimate far earlier, at much greater distances, which could only mean one thing: it was made of more exotic materials. Spectral analysis confirmed it. The comet's coma contained traces of carbon monoxide and carbon dioxide, substances that require far less heat to vaporize than water. These gases don't last long in the heat of a young planetary system. They're the first to be lost, burned off, or eroded away by time and sunlight. The fact that 3 Atlas still carried them after 7 billion years meant its core had remained untouched. Deep within this 7-mile-wide structure were materials that had never once been warmed by a star. The chemistry wasn't just rare, it was ancient, preserved in a way that no other known comet had ever demonstrated. This gave scientists a unique opportunity. For the first time, they could observe the early activation of an interstellar comet as it began its approach, not just after it had passed or when it was already too late. They could measure the rate of gas release, analyze the dust composition, and trace how the coma evolved hour by hour as the object moved through new regions of solar radiation. Every shift in brightness, every spectral fingerprint, every plume of sublimated gas told a new part of the story: where the comet had come from, how it was formed, and what kind of star system it might once have orbited. And because the object was so large, it acted like a slow-burning chemical archive. Unlike smaller comets that quickly shed their surface layers and lose definition, 3 Atlas was waking up gradually, peeling back its secrets one molecular layer at a time. But it was also a reminder of how brief this moment would be. The comet's increasing activity signaled that the inner heat of the solar system was beginning to take its toll. The delicate balance that had preserved its structure for billions of years was now unraveling. It was magnificent. Yes, but it was also fragile. The same sunlight that revealed its secrets was also destroying them, piece by piece. And as it continued its plunge inward, that process would only accelerate. The world was watching a ghost come alive, not with sound or movement, but with chemistry. A body that had wandered the darkness in silence was now shining in full view, speaking in the language of light, and reminding us just how much of the universe is still out there waiting to wake up. By the time the full scale of the object was understood and the earliest signs of activity were confirmed, the astronomical community faced an inescapable truth. The clock was already ticking. 3 Atlas was moving fast, too fast for comfort, and its path through the solar system was unforgiving. It would reach its closest point to the Sun by early September, at which point it would swing behind the solar disk from Earth's perspective. Once that happened, it would be lost in the blinding light of the Sun, completely invisible to our instruments for weeks. And when it emerged again, it would already be on its way out of the solar system, fading rapidly into the void. This wasn't a long-term research subject. It wasn't a target we could return to next year or revisit with another telescope. It was a cosmic once only, and the window to study it was collapsing fast. That urgency sparked a kind of quiet panic among scientists. All around the world, observatories began to reshuffle their schedules. Large telescopes that typically book viewing time years in advance were forced to cancel long-planned projects in favor of this unexpected visitor. The Hubble Space Telescope diverted its resources. The James Webb Space Telescope, still in its early operational phase, allocated emergency time for targeted observations. Ground-based observatories in Chile, Hawaii, Spain, and South Africa coordinated their coverage to provide near-continuous imaging while the object remained visible. The European Southern Observatory issued a rare cross-team directive: study this object now or risk losing its secrets forever. But it wasn't just the big institutions. Amateur astronomers, backyard stargazers, armed with passion and increasingly sophisticated tools, jumped into action as well. Through platforms like the Unistellar Network and the Minor Planet Center's public tracking pages, thousands of citizen scientists began capturing their own images of 3 Atlas. Individually, their data points were simple, but together they formed a near-constant watch of the object, filling in observational gaps between the massive research facilities. In a time when astronomy can sometimes feel like the realm of billion-dollar machines and deep space probes, the comet's approach sparked something rare: a global collaboration between professionals and amateurs, united by the fleeting presence of a visitor from the stars. Behind the scenes, data was being shared at lightning speed. Spectral scans were uploaded to open-access archives within hours of being recorded. Light curves, photometric models, and dust ejection simulations were fed into global databases. Teams that usually competed for telescope time were suddenly coordinating their strategies like first responders at the scene of a disaster. Because in a sense, that's exactly what this was. A slow-motion cosmic emergency. A once-in-a-billion-year object had entered our system unannounced, and we had only weeks to decode it before it was gone. There would be no second chances, no return orbits, no mission extensions. It became clear that 3 Atlas wasn't just a scientific target. It was a test of how quickly the world's astronomical infrastructure could respond to a true deep space anomaly. A test of how agile our instruments really were, how connected our networks could be, and how much information we could extract in a race against the fading light. And perhaps most of all, it was a test of our curiosity, of our ability to rise to the occasion when the universe briefly parts its curtains and allows us to glimpse something truly ancient, truly alien, and utterly irreplaceable. We were watching a cosmic relic pass through our sky, and there would never be another moment like it. Just as Earth-based astronomers were preparing for the agonizing reality of losing 3 Atlas behind the Sun, another twist in the story emerged, one that almost seemed too perfectly timed to be real. New trajectory projections revealed that the comet wouldn't just pass through the solar system, it would swing close, very close to Mars. At its nearest point, it would come within just 0.4 astronomical units of the red planet. That's about 37 million miles closer than Venus ever gets to Earth. On a galactic scale, that's a hair's breadth. And more importantly, it meant that while Earth would be blind during the comet's peak activity, Mars wouldn't be. It would have a front-row seat to the comet's most dramatic moment. For planetary scientists, this wasn't just luck. It was an opportunity so rare that it felt like science fiction. Mars, unlike any other planet, is currently home to an entire fleet of robotic observers. High above its surface, orbiters like NASA's Mars Reconnaissance Orbiter and the European Space Agency's Mars Express had eyes capable of capturing detailed images, spectral data, atmospheric phenomena. On the ground, the Perseverance and Curiosity rovers were equipped with wide-angle sky cameras and sensors capable of detecting subtle changes in light and particle activity. For the first time in human history, we had the technology to observe a truly interstellar object, not just from one planet, but from 2. And just as Earth's window was closing, Mars's was opening. The implications were huge. Observing the comet from Mars would allow scientists to capture angles and wavelengths that were impossible to see from Earth. Mars orbiters could track the evolution of the tail in detail, observing how it stretched and bent under solar wind pressure. Spectrometers could measure the gas composition of the coma as the comet heated up, mapping the release of volatiles in near real time. And perhaps most exciting of all, some scientists believed that small particles from the comet's tail, microscopic fragments of ancient dust and ice, could actually enter the Martian atmosphere. If that happened, orbiters or even surface cameras could witness interstellar meteor trails streaking across the Martian sky. Immediately, mission teams began working on emergency observation campaigns. Schedules were rewritten. Observation windows were drafted and simulated. Instruments that hadn't been used in years were reactivated and recalibrated. Everyone understood how rare this was. The last time an interstellar object passed close to a planet, we didn't even know what we were looking at. This time we did, and we had the tools to see it from a completely different world. What made it even more intriguing was the geometry of the flyby. From Mars's vantage point, the comet would appear near opposition, meaning it would be in the dark sky, directly opposite the Sun, perfectly positioned for imaging with minimal interference. In other words, while Earth was staring helplessly at the Sun, unable to see anything, Mars would be staring directly at the comet. This uncanny alignment added another layer to the growing sense of cosmic choreography, as if somehow everything had lined up just right, not for convenience, but for observation. The universe, unplanned and indifferent as it may be, had handed us a story too perfect to ignore. Of course, most scientists agreed. It was just coincidence. Orbits are complex, and close planetary passes aren't uncommon on long interstellar paths. But still, some couldn't help but marvel at the timing. Just as our own sky went blind, another world, our robotic outpost in the desert of space, was ready to pick up the watch. A silent handoff between planets, a relay race across the solar system with one ancient object as the torch. And for those few weeks, Mars wasn't just a red dot in the sky. It became the universe's only eyewitness to a moment 7 billion years in the making. As the data streamed in from Earth, Mars, and every corner of the sky, something curious began to happen. Amid all the legitimate science, the light curves, the spectroscopy, the coma analysis, a different kind of conversation was beginning to stir. It didn't start with YouTube videos or wild conspiracy posts. It started, quietly and seriously, in the academic community. A single preprint, a paper, unreviewed, cautious and speculative, that asked a question most scientists were reluctant to put into words. What if 3 Atlas isn't entirely natural? The author was no stranger to controversy. Avi Loeb, the Harvard astrophysicist known for proposing that the interstellar object Oumuamua might have been artificial, had returned with a new hypothesis. He didn't claim 3 Atlas was alien. He didn't argue it was a ship or a probe or anything out of a sci-fi movie. What he did suggest was that its unusual properties, the early activation, the massive size, the precise geometry of its flyby, and the frustrating timing of its solar conjunction warranted a deeper look. He proposed that we just consider, whether 3 Atlas might be an example of advanced technology disguised as a comet, maybe not by intent, but by design, camouflaged in a way we'd never detect unless we looked closer. The paper set off a firestorm. Some researchers dismissed it immediately, calling it speculative noise that distracted from real science. Others were more measured, acknowledging that while the alien hypothesis was wildly unlikely, it wasn't unscientific to ask questions, so long as those questions were grounded in evidence. But in the public imagination, the idea took off like wildfire. News outlets pounced. Headlines shouted that an alien spacecraft might be in our solar system. Podcasts and videos dissected the comet's every detail, trying to connect dots that scientists never intended. It became a cultural phenomenon, part scientific curiosity, part myth-making, part cosmic yearning. And to be fair, the timing was strange. The comet had entered the solar system in complete silence. It had evaded detection for months, approaching from the galactic center, one of the most crowded, confusing parts of the sky. Its path carried it close to Mars, while avoiding Earth. It reached perihelion, the closest point to the Sun, during a period when Earth couldn't observe it, and then it would vanish forever. It was the most perfectly unobservable object at the most crucial moment in its evolution. To some, that seemed like nature. To others, it felt engineered. But the data told a different story. Every reading from Hubble Webb, Mars orbiters, and ground-based telescopes confirmed the comet's natural composition. No metals, no energy signatures, no structural patterns, just water ice, silicates, carbon dioxide, and ancient dust materials found in every known comet, just preserved for far longer. Its behavior was strange, yes, but not unexplainable. The early outgassing was likely due to unusually high levels of supervolatiles, the flyby of Mars, coincidence, the timing with the Sun. Unfortunate, but statistically plausible. The more data came in, the harder it became to support any artificial hypothesis, not because of bias, but because of physics. Still, the idea wouldn't fully go away. Not because it was likely, but because it touched something deeper, a kind of cosmic intuition, the sense that the universe might be bigger, older, and more crowded than we've ever dared to admit. It's easy to mock the alien question, but behind every wild claim is a simple truth. We are still new to this, new to interstellar objects, new to detecting them, new to understanding the scale and behavior of our galaxy. And if even one of them weren't natural, if even one object was something more, it would change everything. In the end, 3 Atlas remained a comet, but the question it sparked will linger. Not because it was answered, but because it reminded us that answers are not always the most important thing. Sometimes the question itself, the act of asking, is what opens the door to the next great discovery. As the comet faded from view and began its long final arc back into the void, the world's telescopes slowly turned away. Not because the object had become less important, but because it had become less visible. The light from its coma thinned. The outgassing quieted. Its magnificent tail, once stretching across millions of kilometers, dispersed into the solar wind. From our perspective on Earth, 3 Atlas was disappearing, slipping into the dark just as quickly as it had arrived. But its presence had left a permanent mark, not just in the data it gave us, but in the way it reshaped the way we think about the solar system and what lies beyond it. What 3 Atlas confirmed, more than anything else, was that the space between stars is not empty. For decades, astronomers had theorized that the Milky Way must be filled with rogue objects, comets, and asteroids ejected from their home systems by gravitational instability, collisions, or the slow decay of stellar chaos. But until recently, we'd never seen one. Oumuamua and Borisov were the first to breach that veil. And now, with 3 Atlas larger, clearer, and more chemically rich than either, there was no denying it. Interstellar visitors are not rare. They're constant. We just weren't looking in the right way. That realization is transformative. It means that our solar system is not isolated. It's porous, open every few years, perhaps even more frequently. Strangers pass through, remnants of long-dead star systems, carriers of molecular messages from across the galaxy. Most go unnoticed, slipping through the black with no activity, no flare, no sign. But some, like this one, give off light. They erupt, they wake up, and when they do, they give us a chance to see not just what they are, but where they came from, and by extension, who we are. The discovery of 3 Atlas has already accelerated plans to catch the next one. New sky survey programs are being fast-tracked. Machine learning tools are being trained to recognize the subtle motion of high-velocity objects hiding in crowded star fields. The Vera Rubin Observatory, once seen as just another wide-field telescope, has become a frontline instrument in the search for galactic debris. Funding has been redirected. Proposal calls have changed. What was once a curiosity has become a new frontier in observational astronomy. And there's another shift too. Less technical, more philosophical, because after 3 Atlas, we're forced to admit that the barriers between worlds aren't as solid as we once thought. The comet brought with it dust from a planetary system that hasn't existed for billions of years. It carried molecules formed around a star that may have long since gone cold. In its coma were the fingerprints of a chemistry shaped by completely different conditions, temperatures, pressures, radiation fields that we've never encountered before. That dust is now part of us. It drifted past Earth. It passed near Mars. Some of it may linger in the upper atmosphere, caught by instruments, captured in data. In a way, the ancient galaxy has already touched us and will never fully wipe it off. For scientists, 3 Atlas was the ultimate confirmation of a quiet truth they've always suspected. The galaxy is old, violent, and full of broken pieces. And those pieces travel. Some of them end up here, and in those brief moments when we notice them, when we stop and look and understand what we're seeing, we get to do something truly rare. We get to read the history of another world without ever leaving our own. 3 Atlas didn't just pass through the solar system. It passed through our understanding. And in doing so, it left a trail far longer than any comet's tail. A trail of questions, of revelations, of new beginnings. Now it's gone. Slipping quietly into the black, 3 Atlas fades, not with a bang, but with the kind of slow, silent departure only the universe knows how to orchestrate. The telescopes have turned away. The data is archived. The headlines have moved on, but what it gave us, what it was, remains. A memory not just of a rare celestial visitor, but of something far more profound, a direct encounter with deep time. Not geological time, not even planetary time, but galactic time. Time that stretches so far back, it begins to lose meaning. 7 billion years. That number is easy to say, impossible to grasp. Before Earth, before the moon, before the sun, this thing was already out there, drifting, waiting, carving a silent path through the vast emptiness between stars, untouched and unchanged. A witness to history no species was alive to record. And for just a moment, an instant really, we saw it. We recognized it. We pointed our instruments, our questions, our collective curiosity towards something that never asked to be noticed. Something that might have otherwise passed through like a ghost, unobserved, unmeasured, unremembered. But this time we were ready, barely. We caught its light. We listened to its chemistry. We mapped its trajectory. We imagined its origin. And in that brief exchange, something shifted. Because 3 Atlas wasn't just another rock, it was evidence. Evidence that the galaxy is moving, breathing, shedding its skin in the form of objects cast out from their birthplaces, carrying stories written in ice and dust. That's what made this encounter different. It wasn't just that it was from another solar system. It was that it was ancient, it was active, it was knowable. It wasn't a mystery to be feared or ignored. It was an opportunity to listen to the past, to trace the lineage of elements across light years, to hear the slow, cold echo of a time before time. And while it didn't send signals or show signs of artificial structure or behave in ways that required fantastical explanations, it did something even more important. It showed us that the boundary between stars is not a wall. It's a membrane, permeable, alive. Things get through. Things will get through, and if we're paying attention, we can learn from them. What we saw with 3 Atlas was more than a comet. It was a messenger, a fragment of the early galaxy, tossed from a collapsing system that may no longer exist, only to drift for eons until the laws of physics aligned just enough to place it in our sky. It could have missed us by 1,000,000 years in either direction, but it didn't. It came now, while we were just barely able to see it, just barely advanced enough to understand what it meant, just curious enough to chase it. And now that it's gone, it leaves behind more than data. It leaves behind momentum. The next object will come, and the one after that. We are no longer blind to the dark spaces between the stars. We are watching. 3 Atlas didn't stay, but for a moment, it crossed our path. And in that moment, it did something almost miraculous. It reminded us that the universe is older, wilder, and far more interconnected than we ever imagined. It reminded us that we're not just living in space, we're part of it.